so on in the background. Make sure you guys mute your watch pages as well. So
I don't have the watch. I don't have the watch page up. I don't put it up.
On my tablet, so.
Yeah, I'll shoot it to you. Just stand by. Stand by, stand by, stand by. So,
I don't have the watch. I don't have.
Yeah. What's up, people? This is Robert Bassano. I got John. I got Luke. Welcome to Planete Veritas. We are going to be talking about some interesting things today. You guys see the title of today's show. It's called What is Really Happening When We Can't Observe? And I say nothing at all. John may say something different. And Luke's got some information to give to people. I've got some things to share. Guys, everything that we talk about, I'm learning. We're all learning. There's stuff that we may think we know a fair amount about that we're sharing with you. I'm not saying that we're trying to teach anyone anything. We're just trying to get some sort of understanding of what's really going on. That's what it comes down to. So the information we share with you guys, you gotta come to your own conclusions on what you want to believe, what you can't believe, what you will consider, and what you won't consider as viable, plausible, possible. Okay? Remember, it's not what you know, it's what you can prove. But just because my proof is what I'm putting out doesn't mean that it's true. Just because what John says and the proof he provides doesn't mean you have to accept it, and so on and vice versa. What we do need on a continual basis is constant feedback. I'm getting a lot of emails from people wanting to have things explained and trying to look at as much information as I possibly can, you know, while I'm going through school and learning this on the fly. I'm learning it on the fly. So what I'm sharing with you guys and what we're all sharing with you guys is stuff that you might already know, stuff you've already been exposed to, stuff you might not know. But what we're trying to do is just put this like a research paper. You need to have a research puzzle. And you got to get all these pieces together to come up with some sort of conclusive statement or claim that this has to be it. And then leave it to someone else to say, nope, that's not it. I've tested that, and here goes what it should be. Not what it is, but what it should be. Okay? And then you just keep going. It just keeps going and keeps going and keeps going. The reason why we focus a lot on the quantum level these past couple of weeks, why we've been talking about this, is because we can't start from where we're at right now, looking at the Earth, looking at our environment, trying to decide, okay, we got to go backwards now. So we're taking everyone backwards on the quantum level, the smallest possible level, and then we're going to try to grow everything outward to come up with the construct that we all see every day and everything that we experience. Okay? And I promised John and a few guys that I would always start the show with playing this one video that I have on my channel, which I'm not going to say basically, but factually shows that the Hubble is nothing but a 43.5-foot tall piece of junk, and it's not where they say it is. And everything NASA do, like we always know, especially with the mass media, is fabricated. So I'm going to just show this quick snippet of this video that's on my channel. Okay, it's called Flat Earth. I think it was called Flat Earth Bullshit. I think that's what I named it. But I'm gonna pull it up and show it to all of you guys one more time. As long as we do these shows, I'm gonna just keep rerunning this. NASA likes rerunning shit to us all the time, so I'm gonna rerun it as well. It's their information, right? It's their information. Let me. So here we go. Play this for all you guys, and again, I want you guys to pay close attention to what this astronaut's movements and you know, in the same frame, pay attention to what the Earth is doing below. Of course, we know that's not the Earth. And pay attention to what this Hubble is supposed to be doing, okay? Just focus on this area right here. Just focus on this. Watch the astronauts' movements. Watch what everything else does. And just have a good laugh, okay? There we go.
Fucking incredible. Absolutely. Wait a minute. We need to go back. Did I just see what I thought I saw?
Sorry.
Did the fucking Earth stop moving? Did I see what I saw? Wait. Hold on a second. This is what I want you people to pay attention to. I'm going to play this again. And I want you to take quick notes. Let's try this shit one more time. I want you to look at this video. And I want you to tell me what you see. The Earth's supposed to be moving. Oh, did you fucking see that? Let's do that again. Let's go back again. Here we go. The Earth's not moving. Ooh, you're free. Fly and be free. Holy shit. Let's do that again. So you saw it. The Earth's not moving. Boom. Start it back up again. Did you see that shit? Holy fucking shit. Look. The Earth's not moving. Boom. Anybody want to fucking tell me that's some fucking video glitch? You want to tell me that's a video glitch? You see the astronaut moving, right? The astronaut's movement is seamless, right? So let's see this again. Astronaut's angle, the Earth is moving now. Are you fucking kidding me? I dare anybody try to fucking debunk this. I dare anyone try to debunk that shit. Two things. They said this mission was canceled. The spacewalk. These two yahoos are outside of the fucking space shuttle. And then we are forced to believe that this shit they're doing is real. Look at the Earth. The Earth fucking stopped. I need to do that fucking in slow motion, man. Hold on. I need to do that in slow motion. Let me do that again. Let me do that again. Let's change the speed of this bad boy. Let's change the speed. I'm gonna do it to a quarter speed. I'm gonna do it at a quarter speed. And here we go. Quarter speed. There goes the astronaut. The Earth's not moving. They release their hands. Now watch. The Earth's not moving. Is the Hubble attached to the Earth by some fucking tether? You gotta be fucking kidding me, man. You have got to be kidding me. I mean, I'd be stupid to say I don't know what to say. I'd be stupid to say I don't know what to say.
Okay, there you go, people. I'll put it in chat for everybody. And I'm going to give the show away to John. John wants to touch base on a few things that he said for the last show. And Johnny, take it away. You're going to be presenting to everyone. And go for it.
Well, hey, thanks, Robert. Are you guys seeing my screen?
I think I did. I presented you to everyone. Hang on.
Okay.
Okay, hang on. Do the present, John?
1 second. So, screen share?
Yeah, screen share. we don't. Okay, there you go. I'm present you to everyone, and there you go. It's all yours.
Hey, thank you, sir. So listen, I wanted to make sure that we didn't lose the punchline of the presentation that we did the last time. Make sure that we didn't lose it in translation. So the punchline here is there's nothing wrong with actual real science. Scientific method, it's empirical and it's logically sound. Here's what's wrong. It's the pretenders, the blue and the red guys. See, when you walk in any educational establishment from grade school through university, science is engraved in gold on the arched ivory entrance where you genuflect before entering, right? But these so-called disciplines aren't science. We just showed why. They don't and inherently can't follow the scientific method. How on earth can you be science when to be science you must follow the scientific method? How can something be a something without having any attributes or characteristics of that something? I mean, is this a eucalyptus tree? Then why are these guys called science, for crying out loud? Crocheting is more scientific than these clowns. They're merely masquerading under the term science and have legions of incoherent fans that merely parrot and propagate that it is science. You know, you always hear, well, science says blah, 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 right? No, it doesn't. Science doesn't have any vocal cords, penmanship, or typing skills. It's not alive. And they're not scientific. So science and the scientific method isn't the problem. It's the fraudulent fairy tale masquerading philosophers flying their incoherent flag under something they're not. So these astrophysics, astronomy, and cosmology, these are the very disciplines telling you that the Earth is a spinning ball, among other numerous logical and scientific atrocities. They're only philosophers with fallacious scientific initials behind their names. There's a big difference between scientific claims and claims that alleged scientists make. And check this out. This is Andreas Osiander. This is the foreword to On the Revolution of Heavenly Spheres, which started it all, or codified it. Anyway, in 1543 by Nicholas Copernicus, right? So listen to this. So far as hypotheses are concerned, let no one expect anything certain from astronomy, which cannot furnish it, like we've been talking about. Lest he accept as the truth ideas conceived for another purpose, and depart from his study, or from this study, a greater fool than when he entered it. So, and this is confirmed in a big way here. Renowned cosmologist George Francis Rayner Ellis, and I quote, "People need to be aware that there's a range of models that could explain the observations. For instance, I can construct you a spherically symmetrical universe with Earth at its center, and you cannot disprove it based on observations. You can only exclude it on philosophical grounds." Check that. So, welcome to philosophy or religion. Only these orators have calculators. And this one speaks volumes. Cosmology may look like a science, but it isn't a science, like we were talking about. A basic tenet of science is that you can do repeatable experiments, but you can't do that in cosmology. So when blind parroters or so-called scientists inevitably wheel out their disheveled train wreck mantra, well, science says, well, this is the ammunition you need, and the ammunition is ICBMs. Go ahead and launch them. So you can destroy them even before they start out. They're philosophers. So there you go.
You know, there's a guy in chat, Scientism. He spells his username PSY, and he actually used the word science, spelling it the same way, saying that it's not science. It's basically a psychological mantra they're pushing.
Exactly.
They're trying to convince you You know, this is what we say it is, and you can't challenge this. We need you to believe this.
That's correct.
Don't ask us how we came up with it. Just understand we put our minds together to agree
That's
that,
correct.
you know, this is the shape of the earth. This is how it works. But can we observe it? No. You can't. They won't allow you to go 90 degrees vertical high enough to actually see the shape, construct, and function of the earth. Period. I mean, when you look at the earth, what they claim to be, you know, from hundreds of thousands of miles away, you don't see the way the atmospheres actually rotate and function and move. You can't even judge the distance, because when they're claiming that they're showing the ISS, right? People say, yeah, can't you see the earth is rotating? The earth is rotating. No, the earth is not rotating. What's moving is supposedly the ISS is 17,000 miles an hour, giving you the appearance and perception that the earth is moving. And when I said that to someone, they were like, well, you know, we just have to assume that this is the speed it's probably moving at. But you can't get anything up there to stay stationary long enough to make a determination that the earth is actually moving. And when I say earth, people, I'm talking about the fixed plane surface. I'm not talking about the other layers in the atmospheres. There's obviously movement up at those levels. But it was interesting to read this comment from this guy in the chat that science should be spelled P-S-Y-E-N-T-I-S, T-I-C-E, science, because it's really it's all psychological.
Well,
it's all psychological.
Well, the masqueraders are using science. You know, science isn't the problem. If they would follow science, you'd never hear from them. So they're masquerading under the name of science, but they're not science. See what I'm saying?
No, it's if we can agree that there's no such thing. What we said the last show, that there is no such thing as science. It's a collective agreement. It's
well,
method.
Science. I mean, it's the scientific method, but they can't use it.
Is there really science?
Yeah.
Is there really science?
Yeah, it's the scientific method, but these guys can't use it. So what they're telling you is science isn't science. They can't follow the method. So that's what the deal is.
Okay. I want to go. You want to go to the delayed choice quantum eraser?
Yeah, the granddaddy of them all.
Now, do you want to go to the video first and then go to that?
The
double slit experiment video, because I put it right on 3 minutes and 33 seconds.
Yeah, I got it right here too.
All right, pull up the go to 3 minutes and 33 seconds.
Yeah, I got it right here.
Yeah, it starts there.
Yeah.
And then what we'll do, we'll show everyone that, and then go to the quantum eraser document, break that down, and then I'm going to do my whole critique thing. So
yeah, that's fine.
Because I'm going to be honest with you. You asked me to look at this several times. I did, and I'm looking at it and I'm thinking to myself, I'll just let you go with it and I'll tell you. I'll share it with everybody.
Okay. Is it
Go ahead.
sharing?
Yeah, it's sharing. You're still sharing.
Okay, this is the granddaddy of them all. This is the
blow up the screen. Blow up the screen so everyone can see it.
So. Oh, I see what you're saying. Okay.
Yeah.
Better?
Yep.
All right. This is the granddaddy of them all, a delayed choice quantum eraser. This is a double slit experiment on nuclear steroids. In all my travels, I have yet to come across any experiment that comes close to the simple and elegant brilliance of this bad boy. And the results are even more breathtaking than the actual experimental design. And once they're understood and reckoned with, it'll become clear. So here we go. This is a good explanation of it.
Collectively arranged experiment.
Is it playing? Is the audio playing?
Yes. Can you hear it?
Can't hear anything.
Can't hear nothing.
You can't hear anything? Maybe. Hey,
Nope.
Robert.
Nope.
Can you play it?
Yeah, let me play it from my side.
Okay.
Let me play it from my side.
All right.
Okay, let's see here. Play it from my side. There we go.
Measurement equipment was not available, thus the experiment was first performed in 1999. Even though the setup looks a little complicated, you will have understood it in a few minutes. Behind the double slit, a beta variable rate crystal is used, which causes the photons from either slit to split into two identical entangled photons with half the frequency of the original photon. Why the splitting is required will become clear in a minute. This yellow lens has the task to redirect photons which have traveled through the first slit and thus up the red path, and photons which traveled through the second slit and thus up the bluish path, so that either one hits the sensor D0 at exactly the same location. The intention behind this is being able to measure at sensor D0 whether a bar or a diffraction pattern is being created by the photon, without being able to determine to which slit the photon originally traveled. The information about which slit it came from is deliberately erased by only using one sensor, which cannot distinguish which slit the photon came from. Now let's first take a look at the red path. A photon flies through the first slit and is split into two identical photons at the beta barium borate crystal. The first of the two identical photons flies towards the yellow lens. The second flies downwards and is redirected by two prisms until it finally hits this green semi-permeable mirror. These three green mirrors have all the same attributes. The green mirror allows light to simply pass through 50% of the time. In the other 50%, the light is completely reflected and thus redirected. The decision of which path the photon travels at these green mirrors is a random process with a 50-50 chance. On average, every second photon is redirected upwards and hits sensor D4. In the other case, the photon is not affected at all and simply travels through the mirror. It then strikes this gray mirror, which simply reflects it, and it reaches this second green mirror. Unfortunately, the depiction of this second green mirror is slightly incorrect, and it should rather be oriented as indicated here, so that the reflection angle matches the setup. From now on, simply...
Now hang on for a second, Jay. I want to stop this to go back to when we first did this. That one video we did with the cartoon animation where when we first talked about the double slit experiment, the problem I had with I looked at this 3 times before we did this show, okay? And it dawned on me. Remember the first video we showed with the cartoon? The guy says that the actual placement of the detector right at the entrance of where the photons would be going through the double slits, that when you actually put the detector there, somehow the photons are aware they're being observed, and they perform completely differently just based on the act of observation. Meaning that some mysterious phenomena, the photon realized it was being watched and didn't behave the same way when there wasn't a detector there. So when we look at this experiment, where we're looking at what? We're looking at 1, 2, 3, 4, 5 detectors that are set up in particular locations, reflecting and refracting light. And then you have the coincidence counter at the end, which is wired up with the detectors, and this guy's giving statistics of, 50% of the time the photon of light doesn't even go through. It actually gets reflected back off and goes in another direction to another detector. See, if you take out the detectors, what happens? What happens if you take out these 5 detectors and you just observe with your own eye to see what, and you still have, I mean, that would mean you don't have the coincidence counter. And that's why I titled this show, What's Really Happening, when we can't observe. Is this double slit experiment actually occurring the way this guy is actually describing it in this video? Because you have 5 detectors, which means that the photons are actually behaving the way we would collectively expect them to behave based on the angles and positions of the detectors, the prism, the other mirrors, their angles, their compositions. You understand where I'm coming from with this? Is that first video we did, where the scientist actually said that the photon behaves completely different when it's being observed versus not being observed. This experiment, based on that first video, is completely invalidated for me.
No, it's not. Let me explain something to you. In that first video, the photon detectors were placed. You see where the blue laser right over by the BBO crystal?
They were placed on that side of the of the double slit.
Yeah, right at the double slits. In this case, they've taken that out of the equation and they moved the detectors downstream.
Okay, and I factor that in. But who's to say that the same thing, just because you change the position of the detectors, you put them on the other side to observe what the photons are doing once they go through the double slit, who's to say the same thing isn't happening on the other side? Where the photons are actually know that once they go through the double slit, there's not a detector on the left-hand side when the photons are fired through the double slit. But as soon as the photons go through the double slit, it says, oh shit, we're being watched, put your clothes back on. We need to perform the way we would if we were being watched on the other side. Everyone get back in line. That's the simplest way I can explain it. There's no way of, see, this experiment, for me, doesn't prove that the same thing is happening on the other side, even though the detectors have been placed on the actual observatory side when the photons have gone through the double slit.
Okay, well, let's see. Go ahead and run the rest of it.
Okay.
Let's see what they say.
Turned by a few degrees. In the first case, the photon is not affected by the mirror, simply travels through it and hits sensor D1. In the second case, it is reflected and hits sensor D2. Now let's take a look at the bluish part of the photons which travel through the second slit. They are also split up to 2 identical photons, and the one traveling downwards is also redirected by prisms. In the first green mirror, every second photon is reflected and hits sensor D3. In the second case, the photon simply travels through the mirror, hits this gray mirror, and subsequently this second green mirror, which you should again imagine to be turned by a few degrees. 50% of all photons travel straight through this mirror and hit sensor D2. The other 50% are reflected and hit sensor D1. First of all, you should understand that photons which traveled through the first slit and thus on the red path can only reach sensors D1, D2, and D4. They can never reach sensor D3. Which of these 3 sensors they actually hit is a random process that depends on the green mirrors, but they will inevitably reach one of these 3 sensors. The same logic applies to the bluish paths. Photons which travel through the second slit can only reach sensors D1, D2, or D3, but never sensor D4. Thus, it should be clear that a photon that hits sensor D4 inevitably traveled through the first slit, because photons who traveled through the second slit have no way to reach sensor D4. The same logic applies for sensor D3. Any photons reaching it must have traveled through the second slit.
Quick second. Now, he used the word logic a few times. Now, correct me if I'm wrong here, he's saying that the photons going through the blue slit can never reach D4 unless, then the only way to reach the fourth detector is to go through the first slit. And this is why I say, what's really happening when we can't observe? Now, let's just say for argument's sake that the photons going through the second slit, the blue slit, if they can reach detector 0, right? And again, these photons are being fired at the same time. So the photons going through the first slit can travel to detector 0, and the ones going through the second slit can go through detector 0. But what's to say that the photons going through the second slit, the blue slit, somehow don't interact with the photons from the first slit, join up, and fuse together to get to the fourth detector? Because but he's saying that it doesn't make, if you use logic. But let's throw logic out the window on this whole thing.
Robert, look at this experiment. On path A, the red path, the only way a photon can hit detector D4 is to come out of A. You can't, if a photon would come out of the blue path, it can't reach D4.
Yeah, but what rule, what law says that that's not possible?
It's right there in front of you. There's no path to it.
I'm looking at it, but what law or rule dictates that that can't happen?
Because the photon is traveling directly to that beam splitter. It can't get to D4.
When you look at this chart, it shows photons going to the 0 detector.
Yeah, because it's designed to. You've got 2 photons, entangled photons, that are generated right after it goes through the double slit. One goes to detector D0, and the other one goes on the path on the path in the experiment. The D0.
So this prism, this Gland-Thompson prism,
right,
which is allowing for these photons to be reflected and refracted to go into these directions. What you're trying to say is that there's no possible way, based on the shape and design of this prism, that photons coming through the second slit don't somehow bounce off the photons from the first slit and then take a linear straight line straight for detector 4. You're saying that is not possible.
That's not possible because there's only a single photon being generated by the laser, and that single photon is split into 2 entangled photons. They're sister photons. One goes to D0.
Sorry about that, guys. Damn it.
Yeah, every time a photon is sent into this experiment, it's split into 2. One of those gets sent to D0, and the other one goes on either of these paths in the rest of the experiment.
Now here's a weird question, which when I looked at this, I started looking to see if someone did this experiment where they actually changed the temperatures of the prisms. Because here's a testable hypothesis. What if you change the temperature of the Gland-Thompson prism in the beginning?
I don't know. Can we?
And that's my point. That's what's really happening when we're not observing. We don't know.
That's not a point. Well, we could put jelly on them too.
Yeah. Well. Yeah, okay. Comical about that one. But I'm telling you here right now, for me personally, I don't believe this.
Okay. Well, let the experiment go.
When I look at this, when I look at what's here, there's a possibility. He's saying 50% of the time, the photon actually gets reflected off to hit this mirror.
Yeah, that's a beam splitter.
But why wouldn't it be possible for this to get reflected off and go immediately to D4 without hitting the mirror?
Well, it either transmits through the beam splitters or gets reflected off. It's due to the angle of the beam splitter.
So they're basing everything on the angles of these prisms and the way they're actually maneuvered to get the light to reflect. But if you change the angle and the position of this prism and this prism, you could literally there's a potential possibility you could get the particles from the second slit to go straight to D4.
Yeah, but that's not set up that way.
Yeah, but why is it set up this way?
Because
And they don't show multiple experiments of changing the angles of these two prisms to see if they can actually get both particles to go straight to D4.
Robert, because that's not the experimental setup.
Yeah, you see, it's another.
Just go ahead, let it run.
Another psychological.
Let it run and let's see
the. You know, something else can't happen simultaneously at the same time.
Yeah. Let's run the experiment and see the results, and then you explain the results when it's done.
Yeah, let me finish playing this.
Go ahead.
For photons which ended up in sensor D1 or D2, it is impossible to determine through which slit they actually traveled, because those two sensors can be reached on the red path from the first slit, as well as on the bluish path from the second slit. Now you have almost understood the setup of the experiment. One element is missing, and that is the function of sensor D0 at the top, and the reason why the photons traveling through either slit had to be split into two entangled photons by the beta variable rate crystal. Sensors D1 to D4 are identical sensors. They can only detect that a photon has hit the sensor, but are not recording any image, whereas sensor D0 is similar to a camera and is able to record the exact location where the photon ended up on the screen. The last aspect that needs to be understood before looking at the results of the experiment is related to the time it takes the photon to travel through the experimental setup. Light travels at the speed of light. Thus, the shorter the path, the earlier the photon reaches the sensor. The experiment is designed in a way so that the path of the photon traveling towards the yellow lens always reaches sensor D0 first, before its entangled partner reaches the first green mirror. Thus, the result of the measurement of sensor D0 is always recorded first, and then, with a short delay, the partner photon hits one of the sensors D1 to D4. The coincidence counter on the right has the task to process the results of the measurements of all 5 sensors. It establishes a connection between the measurement results of sensor D0 with the entangled photon detected by sensor D1 to D4. This way, each single photon measured by sensor D0 can be precisely assigned to one of the sensors D1 to D4, where its entangled partner was measured. The measurement data of sensor D0 can thus be split up into 4 individual images, each assigned precisely to one of the sensors D1 to D4. This picture depicts the raw measurement data of sensor D0 on the upper left. This raw data only shows a white bar of light in the center of the screen. So, in this raw state, this data is pretty much useless. It is only when each individual spot of light of the raw data is assigned to the sensors D1 to D4, where the entangled partner photon was measured, that a pattern becomes visible. 2 aspects stand out immediately. The data assigned to sensor D1 and D2 shows an interference pattern, while the data assigned to sensor D3 and D4 shows no interference pattern. For photons which reach sensor D1 or D2, it is impossible to determine through which of the 2 slits they traveled, since the path information has been erased by the 50-50 chance events at the green mirrors. The entangled partner always creates an interference pattern, similar to the double slit experiment without photodetectors at the slits.
Wait. I remember seeing this and listening to it. Why the hell would the information be erased?
Because if you look at the experimental setup, any photons that hit D1 or D2 is obfuscated here in the experimental setup, because it can come out of path A or path B. You see the blue and red lines?
Yeah.
There's no which path information you have. It could be A or B. But
so the fact that the coincidence counter can't determine which slit the photons came out of once they hit D1 or D2, because it can't detect where the photons came from, it immediately just erases the data?
No, it's comparing. You're getting data. See, when these photons are hitting these detectors D1, D2, D3, and D4, they're not taking any measurement, like position measurement. The only measurement is being taken at D0 from its entangled photon that was fired 8 nanoseconds before it. So these are just sending electrical pulses to the coincident counter.
But it's detecting something that hit. It's
Yeah.
detecting photons that hit D1 and D2.
Yeah. Yeah. And the interference pattern or the no interference pattern is showing up on D0.
Okay, but how do they determine there's no interference?
They're showing you right here. These are the patterns that are coming
When
out.
he talks about the data being erased, I'm taking that is that the data is not being erased.
No.
The data is still there.
No.
It's just not on a detectable level.
No, the data is not being erased. The path information is being erased.
Okay, well, okay, let me correct myself. Path information. The path information is being erased not because it shouldn't be accounted for. It's there. It's not detectable.
It's just obfuscated. Correct, Robert. It's a better word would be to say that it's not erased. It's just obfuscated. You don't.
But why would they say that it's being erased and just saying what you just said, obfuscated, and that it's still there, but it's just not at a detectable level for the experiment?
Yeah, they just call them eraser experiments. It's the same thing, obfuscated or erased.
Yeah, that just kind of explains why we keep fucking making mistakes in a lot of shit.
Yeah, it is a language.
If it can't be detected, they're just saying, okay, it just doesn't exist. Which means that when we're not looking, there's a whole bunch of shit happening we just can't observe. And we come up with all of this science and this mathematics to try to explain, well, you know, you can't account for this data because this data is not consistent with the majority of the data that's being put out. So the fact that we can't explain it, why don't we just discard it?
Now, look at what you have here in your results. Detector D1, D2, D3, and D4. Why are you getting an interference pattern at detectors D1 and D2, and you're not getting them at D3 and D4? So you need, and the only explanation is because of the experimental setup. D3 and D4, whenever a photon hits one of those detectors, you know exactly which path it took, because it can only take one path due to the experimental setup. Right? So it's only one path.
The way to make this experiment better is to conduct simultaneous variants of this experiment, changing the mirrors so that you could actually get the same pattern that you have on D1 and D2 with D3 and D4.
You can't. The only way you can do that.
Yeah, but John, come on, bro. Listen, you know.
The results
you keep saying we can't. That word just don't jive with me. You saying we can't, but no one's done it.
Well, Robert, look at these results.
I know, I'm looking at these results. But when you say it can't, there's no way an experiment can be conducted so that you get the same pattern on D3 and D4. The fixed positions of these detectors.
Yeah, there is. Yeah, there is. All you have to do is know the path information, and you can duplicate these patterns.
Okay, so how would you go about knowing the path information?
You know, set up the experiment where there's only one path to that detector, like in this experiment. It's already doing it for you.
Yeah, and the way the experiment will be set up is changing the angle of those prisms.
It's got to do, yeah. I don't understand where you're trying to go with it.
No, I mean you do, Jay. Come on, the prisms is what's directing the photons.
Don't worry about the prism. Don't worry about the.
Don't worry about the prisms. That's
they're not. They're.
The prisms are affecting the path.
Yes, because they're set up that way.
Okay, so you're saying don't worry. If I take the prisms out of it, what happens?
If you then you don't have any experiment. You're not doing the experiment.
Okay, so the double slit experiment has been debunked.
It's not debunked. Let it go. Let it go. Let's go ahead and finish it.
Let me see.
For photons which reach intensity 3 or D4, the path of the photon to the first or the second slit can be identified. The entangled partner does not create an interference pattern, similar to the double slit experiment with photon detectors at each slit. Why should this result really make us think about the nature of reality? Well, the problem with this result is that the photon that travels on the upper path reaches sensor D0 at a time when its entangled partner photon is not even in the first green mirror. At this moment, the photon cannot really know whether it should create an interference pattern or not, because due to the longer path, the result, which sensor its entangled partner has traveled to, is still undetermined. How can the upper photon know in advance for each individual measurement on which path its entangled partner will be traveling through the green mirrors? It cannot know, because this decision in the green mirrors is a random event with a 50-50 chance. Nevertheless, the results show that obviously the upper photon knew exactly what to do in each case. Otherwise, the data assigned to sensors D1 or D2 would not form an interference pattern, while the data assigned to sensors D3 or D4 shows no interference pattern. Did you grasp the paradoxical nature of the results of this experiment? In case you didn't, maybe jump back and rewatch the last few minutes. What do scientists have to say about the results of this experiment? When approaching the results of the delayed choice quantum arrays experiment with Newtonian physics and a purely materialistic worldview, there is no way of explaining its results. Thus, many scientists simply avoid the entire topic because it seems as if causality and time are being violated here. While the formulas of quantum physics can describe the effect mathematically, it is difficult for any layman to grasp these rather abstract derivations and conclusions. As an alternative to these sophisticated formulas, I would like to present you now in the third chapter of this video with a model of reality physicist Thomas Campbell has come up with, because his model can explain these strange results in easy language.
You want to go down here, Robert, or you want to stop it?
Reality is a workshop in about 16 hours. Since only
well, that's up to you. Do you want to go into his discussion?
No, I don't want to go too far into it. It was interesting that he says that because this defies what they it defies what causality in time.
That's right. Exactly.
They want to stick to the Newtonian and Einstein. They want to stick to the Einsteinian idea of causality in time, and because they can't explain this, they're just like, okay, whatever, we can't use this.
Yeah. I've had many people. I've brought this up to university professors. They just start calling me names. Listen, this experiment, in summary, it shows that knowledge existing or knowing the which path information alone causes wave function collapse.
Yeah.
Number two, decoherence, that is the physical interaction of quanta with a measuring device, does not cause wave function collapse. And number three, QM phenomena transcend space and time. That means they are utterly meaningless, and causality is violated. So you can't get around it. You can't get around it.
You want to pull up the document on delayed choice quantum erasure?
The actual study?
Yeah.
Go ahead.
Let me pull it up. Hang on a second.
And
I'm not saying that I completely. Well, I'm not going to make any claims that I understand that fucking thing, because.
Well, it takes about 50 times.
The fact that it's a static experiment is what it is.
What do you mean static?
Well, static meaning that they decided, okay, probably through their own experimentation, let's stick with this variable we put together, because they've probably tried a multiple of variables to determine which position the prisms had to be placed in, the angles of the mirrors.
Robert, all the prisms and all that stuff is a basic interferometer.
Well, I would have loved to see the actual physical experiment in a video.
Yeah, I would love to see it too. But go ahead and pull up the actual study.
I'm pulling it up right now. Pulling it up right now.
All right, go ahead and scroll down to the left-hand side.
Yeah, hang on. I just pulled it up. So this is the delayed choice quantum eraser study. It's based on that video we just saw, people. Where do you want me to go to?
Yeah, go down the left-hand side. Go down one more. Okay, hold up. Go ahead, scroll up a little bit. Okay. Start reading. Just start reading from "We Wish." It's a new paragraph. It's down in the middle.
Right here.
Yeah, go ahead.
Okay. Let me pull that so everybody can see that.
Okay.
Okay. We wish to report a realization of the above quantum eraser experiment. The schematic diagram of the experimental setup is shown in Figure 2. Instead of atomic cascade decay, I don't even understand where that even played a role in this.
Well, that's because they did that. Just keep it explaining.
Yeah. Spontaneous parametric down conversion is used to prepare the entangled two-photon state. Jesus. The spontaneous parametric down conversion is a spontaneous nonlinear optical process from which a pair of signal idler photons is generated when a pump laser beam is incident onto a nonlinear optical crystal. In this experiment, the 351.1 nanometer argon ion pump laser beam is divided by a double slit and incident onto a type 2 phase matching nonlinear optical crystal BBO at two regions, A and B. A pair of 702.2 nanometer orthogonally polarized signal idler photon is generated either from A or B. The width of the SPDC region is about 0.3 millimeters, and the distance between the center A and B is about 0.7 millimeters. A Glenn-Thompson prism is used to split the orthogonally polarized signal and idler. The signal photon 1, either A or B, passes a lens LS to meet detector DO, which is placed on the Fourier transform plane, focal point plane from a collimated light beam of the lens. The use of lens LS is to achieve the Fairfield condition, but still keep a short distance between the slit and the detector DO. Detector DO can be scanned along its x-axis by a step motor. You know what? Let me tell you what. This is
keep going. It's going to tell you in 1 second.
Dude. This is highly fucking complex for everybody that's probably listening in chat, dude, because it's fucking scrambling my brain right now.
Okay, it says the
process that took place.
The interferometer.
The interferometer includes a prism PS2 50-50 beam splitters, BSA, BSB, 2 reflecting mirrors, MA, MB, and a 50-50 beam splitter BS. Bullshit.
There you go.
Bullshit.
Yeah, BS.
That's what I have to say. Bullshit. Yeah, they got that right. They got that right in this document, because let me tell you something. I'm reading through this and I got it now. I got this now.
You do?
Okay.
Yes.
Okay, then go ahead and explain the results.
No. Hold on. Let me read down to this part right here.
Good.
Detectors doing a detour are placed at the 2 output ports of the BS, respectively, for erasing the witch path information. They set this fucking experiment up to literally create the invalidation of the undetectable path.
What?
No, because remember when the guy says that the paths of those 2 photons are erased?
Yeah, they're obfuscated.
You want me to go back? They are obfuscated. They didn't use that in this paper.
It's the same thing.
Oh no, it's not the same thing, John, to me. What they're saying is that, well, we couldn't set up the experiment to detect everything. We could only set up the experiment to literally recreate the possibility that the photon path, we know it's going to be undetectable because there's a 50-50 chance it will or will not show up. So we're going to set the experiment up to prove what we believe may be happening.
All right. Go ahead and explain the results.
The triggers of detectors D3 and D4 provide which path information of the idler, photon 2, and in turn provide which path information of the signal, photon 1. The electronic output pulses of detectors D1 and D2, was this paper go all the way back up? D3 and D4 are sent to coincidence circuits with the output pulse of detector D0, respectively, for the counting of joint detection rates R01, O2, O3, and O4. In this experiment, the optical delay is chosen to be equal to 2.5 meters, where L0 is the optical distance between the output surface of BBO and detector DO, and Li is the optical distance between the output surface of the BBO and detectors D1, D2, D3, and D4, respectively. This means that any information one can learn from the photon 2 must be at least 8 nanoseconds later than what has learned from the registration of photon 1, compared to the 1 nanosecond response of the detectors. So wait a minute, whoa. So the detectors have a 1 nanosecond response time, but they're saying the actual detection is not taking place till 8 nanoseconds later.
Yeah, the difference between D0 is hit by a photon 8 nanoseconds before any of the other detectors are hit.
Yeah, this whole experiment just looks completely bullshit contrived. Yeah, I agree with him. It totally goes against what the rest of science wants us to believe.
Every experiment is contrived. That's the whole point.
Well,
you have to contrive it. You have to have controls.
Well, I don't agree with the obfuscation that they're just totally disregarding the fact that there's something happening. They just can't detect it. So
they're not disregarding anything. They're sending photons on one of two paths. One path is a known path. The other path is an unknown path. If you send these two photons on a known path and an unknown path, what happens? What is the result? So on a known path, there's no interference, clearly from this experiment. On an unknown path, there's interference. That's what it's telling you.
You remember the first show we did and what you said, right?
What?
With regard to information.
Right. Which path information? Correct.
Which means that something is sending that information to that photon to tell it what to do.
No. Well, the experimental setup hides the independent variable in this experiment. The independent variable is known path versus unknown path. And you have two unknown paths. Detectors 1 and 2. Detectors D3 and D4 are known. So look at the detectors and tell me why D1 and D2 show interference and D3 and D4 don't.
Okay, forgive me for this. I want to use a little bit of logic, like this guy said in the video. Logic. Let's go with what you said. Known path and unknown path.
That's correct.
Okay. How could there be an unknown path when they actually describe how they set up the whole experiment?
Pull up the experiment.
Get the experiment up. They describe how they set this experiment up, which means that they already know what's going to happen.
No, they don't. They just put this is an experiment. It's judging two outcomes. A known path, you set up a known path, and then you set up an unknown path, and then you look at the results and say, is there any difference here?
But look at, I'm going back to logic. How can you set up an unknown path? Listen to the words. Unknown. How can you set an unknown path? That's like saying, hey, you know what? Let's go inside this cave. Luke, you go down there. I know where that goes to. Robert, you go down there. I'm going to go down here because I've never been there before.
Robert, it's the experimental setup. Look, pull the experiment up again.
But that's what I'm saying. We're both going into the same cave. We're just going down different rabbit holes. You know.
I'm going to show you. Pull up the experiment. Pull up the design of the experiment. Go back to the video. I'm going to show you how you do it.
Okay, hang on a second.
Yeah, go out of this. Pull up the, or give it to me.
Well, go in the watch page and click the link.
Okay. Screen share.
Are you sharing your screen?
1 second.
I'm
1
just.
second.
I'm not sure. Am I not getting it?
Yeah, well, it's, you know what? This is a pretty complicated
That's how I
experiment.
look at it. I look at it as though me, you, and Luke are going into the same cave. We're just taking two different directions. And you're saying that there's a known path and an unknown path.
That's correct.
We're going inside the same cave. We know one leads to some underground river, and the other one, we don't know where it leads, but we know it's going to end up somewhere.
Okay, let me show you.
And Marcus is waiting on the other end. He's the coincidence counter.
Wait a second.
He's tracking all of us. He knows exactly where we are
Come down.
and what path we took to get there.
Okay, the experimental setup. So, follow the blue line this direction, right?
Okay.
This is path B. The blue line is path B. So if we shoot entangled photons, one goes that direction. We're not worried about that one right now. We're worried about the one going here. So you look at this experiment and say, okay, this photon has a 50-50 chance of being transmitted through this beam splitter or being reflected down the D3. Is there any possible way that a photon fired out of the red path can hit D3 in this experiment?
Well, I don't know, because I actually can't see this happening.
No, it can't hit it. There's no way it can get down to D3 from path A. Now, the unknown path where it's obfuscated is it has two choices, because once it goes through these beam splitters, it could either come out of path A or path B, right?
Okay.
See the red and blue lines?
Yeah.
We don't know which of these two slits that it went through, so it acts as if it goes through both at the same time. We don't have the which path information with D1 or D2 because there's two choices. It could either come through A or B. But due to the experimental setup, they obfuscate which path that it can come through because it can come by A or B. Whereas D4 and D3 is only one path.
Well, I got one person on my side in the chat.
Well, they could be on your side all day long.
I'm agreeing with him that a single photon isn't emitted or detected, and the equipment doesn't work like that in reality.
So a hand wave dismissal of the whole experiment. That's
No, it's not a hand way of dismissal. What I'm saying is this: is that it's a fixed experiment designed.
Every experiment.
Well, yeah, you're right about that. But the fact of the matter is that they don't explain how they came about designing it.
Yeah, they did. You just read it.
I just did read it, and they said it clear. It's
They
fucking
said it's
BS.
what?
It's fucking BS.
That's the beam splitter.
I know what the letter stands for. I'm saying it stands for bullshit.
Yeah, well, show it.
It's bullshit.
Well, anyone can label it. Go ahead and show it. I don't know why it's BS.
Well, let me recant. I'm not gonna say that there's no photons being emitted, but it would have been nice.
Yeah, especially when they're hitting the detectors.
Well, we don't know what the hell's hitting those detectors.
Yeah, it could be mice.
Yeah, could be fucking dandruff.
Yeah, right.
Hey guys,
could be somebody sneezing on the damn thing. Who knows? But the fact of the matter is this: the issue I had when I watched the video 3 times, Jay. I really did after you and I talked yesterday, and I kept listening to him saying that the information was being erased. The path information was being erased, and I'm like, wait a minute, why? And I read through the paper, and I'm like, wait a minute. How did they even determine the distance and how many detectors to use? You know, what was the frequency and wavelength of the photons being emitted? You know, the speed. You know, I can see why they put the laser right up against the double slit. But what if you put the laser was quite a distance away from the double slit? What do you have then? What happens then?
It wouldn't matter.
It wouldn't matter.
That's right.
Can you show us?
What if we put jelly on the beam splitters? I mean, we could talk all this all day long, but that's not what the experimental design is. I mean, it's crystal clear. Now, you may have to watch it 53 times.
No, is it really crystal clear?
It's crystal clear to me.
Guys, my idea on this is that
And I can show you another 30. I can show you another 30 of them that duplicated it.
Yeah.
Yeah.
Okay.
So they're on to something.
I'm actually in the process of learning this right now, and
listen, to be fair,
till I get through maybe 2-3 more classes, this is definitely going to be something I'm going to discuss, and I'm going to see what happens. Either I'm going to get kicked out or I'm going to fail.
Hey, to be fair, Robert, this is a pretty complicated experiment.
Because I'm actually taking an optical physics course
right
in the fall, and I think I'm going to talk about this. I'm not saying I don't completely get it, but when I see the term delayed choice quantum eraser, and you're throwing time in here, and then scientists are saying they don't want to even discuss this because it goes against what they believe.
Yeah, because they're materialist scientists.
They're saying they disagree with this. Because it defies what they think they know with regard to causality and time.
Well, okay, now you have to define scientist, and then you have to define materialist versus a non-materialist scientist.
Look,
because a materialist scientist can't explain this.
Yeah, my boy Scientism explained it. Scientists are people with fucking head issues, man.
Well
they got psychological issues. They got psychological issues. Now, I'm not saying that you have a psychological issue. I mean, you're giving us reason and clarity behind this kind of stuff, but I need to look into this a little bit more.
Yeah,
I'm not dispensing with it. I'm not completely dispensing with it because it's the right thing to dispense with it. I'm saying that I see problems.
There is no problem.
Logical problems with this.
And all these delayed choice quantum eraser experiments were mainly birthed by John Wheeler at Princeton.
Okay.
He thought of these. They thought, see, they couldn't make these things back in those days because they didn't have the technology to bring it to fruition.
Yeah.
So they just sat there and thought about experimental designs to test different aspects of quantum phenomena. And I'll tell you what, you ain't getting any better than this one.
Yeah, I understand. Well, to end that note, because we're definitely gonna have to look into this more. Okay, for sure.
Yeah.
You and I are gonna need to talk about this offline so that we can, because I want to be able to do another video that's even more dumbed down, where we can maybe put something together in a virtual experiment with that physics virtual lab stuff application.